Now we will do problem based on AP. So the problem is for an AP, that is 2, 5, 8, 11, so on, find 15th and 18th term of an AP, that is arithmetic progression. Now, as we know, nth term of an AP is given by an is equal to, or we can say Tn is equal to a plus n minus 1d. So we'll use here Tn. Here a is the first term, that is 2, and d is the difference of consecutive term, that is 5 minus 2 is equal to 3. So Tn term is 2 plus n minus 1 into 3. Now we have to find 15 term, that is T15. That is 2 plus 15 minus 1 is 14. 14 into 3 is 42. So 2 plus 42 is equal to 44. Therefore T15 is 44. Now T18. That is 2 plus 18 minus 1 into 3. That is 2 plus 17 into 3 is 51. So T18 is 53. So these was two terms that we get. Now the next problem is which term of the AP, that is 3, 14, 25, 36 will be 121, 121 less than its 37th term. So we have to find that term which is 121 less than its 37th term. That is T37 minus 121 is equal to required term. So now the solution is, let Tn be the required term. Here a is equal to 3 and d is equal to 14 minus 3 is equal to 11 and n is equal to 37. So first of all we will find out T37, that is a plus 37 minus 1d. A is 3 plus 36 into 3. Sorry, d is 11. So we get 3 plus 396, that is 399. This is T37. Now according to question, we have to find the term which is 121 less than 37. So we suppose T and D are that required term, so it becomes T37 minus 121. So it is 399 minus 121. That gives Tn is equal to 278. Now we have to find the n. Tn is a plus n minus 1d, that is equal to 278. Here a is 3 plus n minus 1, d is 11, that is 278. That gives n minus 1 into 11, that is 278 minus 3 is 275. So we get n minus 1 is equal to 275 over 11. That gives n minus 1 is equal to 25. So we get n is equal to 26. Thus the 26 is the required term that is 121 less than the 37 term. Now the next problem is if the 11th term of an AP is 0, then prove that its 31st term is double the 21st term. Now the solution is here Tn is equal to a plus n minus 1d. As 11 term is 0, so T11 is a plus 11 minus 1d. This is equal to 0, so we get a plus 10d is equal to 0. That implies a is equal to minus 10d. That is a relation between a and d. Now we have to prove 2 times of T21, that is 2 times of a plus 20 minus 1d is 21 minus 1d is 20d. We have to prove this is equal to T31. So we get 2a plus 40d, that is a plus 30d plus a plus 10d. Or we can say a plus 10d is equal to 0, or by substituting value of a is equal to minus 10d, we get this term is equal to 0. So this becomes a plus 30d, and a plus 30d can be written as a plus 31 minus 1d, that is T31 term. That is our required result. Therefore, T31 is equal to 2 times T21, which is our required result. Now the next problem is that is if the period term of an AP is Q and the covered term is P and P is not equal to Q, then find the nth term of the AP. Now the solution is we have P term is equal to Q, that is A plus P minus 1D is equal to P minus 1D is equal to Q, and TQ term is P, that is A plus Q minus 1D is equal to P. This is number 1 and this is number 2. So we will get the value of A and D from these equations. Now 1 minus 2 implies P minus 1D minus q minus 1d is equal to q minus p. That gives p minus 1 minus q plus 1 outside d as common. So from this on cutting we get d is equal to minus p minus q over p minus q. That is equal to minus 1. Taking minus from here and here we get p minus q. 1 and 1 will be cancelled out. Therefore d is equal to minus 1. Now we have to find a. So from number 1 or 2, whatever be, a plus p minus 1d, that is minus 1, is equal to q. So we get a is equal to q plus p minus 1. This is the value of a. Now we have to find Tn. Therefore Tn is equal to a plus n minus 1d. That is a is p plus q minus 1 plus n minus 1 into minus 1. So we get p plus q minus 1 plus n plus 1, that is p plus q minus n. Therefore Tn term of given sequence is p plus q minus n. That is a required formula for Tn term of given sequence.